Hey makers, welcome back to Hub360 Embedded Sphere, your favorite stop for IoT and embedded projects. In today's tutorial, we'll be building a voice-controlled car using ESP32 and a custom MIT App Inventor mode. In today's tutorial, we'll be building a voice-controlled car using the ESP32 and a custom MIT App Inventor Bluetooth app. You'll be able to control your car using simple voice commands like forward, left, right, backward, and stop. Let's get started. Components used. We'll be using an ES32 development board, an L298N motor driver module, two DC motors for left and right drive, 7.4-volt Lion battery pack, jumper wires, and also a robot car chassis. First, we'll start with the motor driver, connecting it to the ES32. First, connect the enable pin to GPIO25 on your ESP32. Next, we'll connect the in-1 pin on the motor driver to the GPIO26 on the ESP32. Next, connect the in-2 pin to the GPIO12 on the ESP32. Next, connect the enable B pin to the GPIO14 on the ESP32. Next, connect the in3 pin to the GPIO27 on the ESP32. And finally, we'll connect the in4 pin to the GPIO13 on the ESP32. Next, we'll connect the motors to the L298N motor driver. First, we'll connect the left motor to each 2 terminal to motor A of the L298N. Next, we connect the right motor to each 2 terminal to motor B of the L298N. Now move to the power connections. Connect the motor driver VCC to the 7.4 volts Lion battery positive wire. Next, we connect the ESP32V in pin to the motor driver 5 volt output. Next, connect the ESP32 ground and the motor driver's ground. Finally, connect the ground of the motor driver to the 7.4 Lion battery ground. Finally, connect the motor driver's ground to the 7.4 Lion battery's negative. Ensure all components share a common ground to prevent erratic motor movements. Let's break down the code step by step. Libraries used. This enables classic Bluetooth communication on the ES32. We'll use it to receive commands from the MIT app via Bluetooth. These pins control L298N motor driver. The ENA and EMB control motor speed using PWM. In 1 to in 4 determine motor rotation direction. The Bluetooth setup. This initializes Bluetooth and sets the visible name to ESP32 car. Pair your phone with this name before connecting through the app. These are the motor control functions. Each direction is handled by a dedicated function. This runs both motors forward briefly then stops. Other functions such as the move backward reverses both motors, turn left spins left wheel backward, right wheel forward, turn right spins right wheel forward, turn right spins right wheel backward, left wheel forward, stop motors stops everything. Command control via Bluetooth. The ESP32 listens for characters sent over Bluetooth. F for forward, B for backward, L for left, R for right, and S for stop. Upload the Arduino code to your ESP32. Power the car using your 7.4 volts Lion battery. On your phone, turn on Bluetooth. Pair with ESP32 car. Open your MIT app. Click Connect button. Tap Speak command and say forward. Watch your car drive off on voice command. Forward, left, left, forward, right, 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 forward, back. And that's it. You have just built your own voice controlled car using ESP32 and MIT App Inventor. In this project, we learned how to set up Bluetooth communication on ESP32, use MIT App Inventor speech recognizer, and also send Bluetooth commands to control a robotic car. All components used are available at hobbyists.com.ng. Like this video if you enjoyed it. Subscribe so you don't miss out. Until next time, keep building, keep innovating. This is Hub360 Embedded Sphere, helping you bring your ideas to life.